Lesson 1.9, compass directions involving word problems, right? Or word problems involving compass directions, I should say. A canoe leaves the dock and travels 3.5 kilometers in direction south 46 degrees west. A second canoe leaves the same dock and travels 4.8 kilometers until the first canoe is directly due south of the second. Okay, so that's very important actually, the directly due south. When you're due south of something, or if something is due south of you, right? Grand Forks is directly due south of Winnipeg. It's directly underneath us in a straight line. It's not like in an angle. It's like it goes along the north-south line. If something is directly due east of you, right, it would be literally straight, like going down east without any angle, be making a 90 with the north-south line. So it's very important, that term, for you to understand that term. In this case, they want us to calculate the distance between the canoes. All right, so we need to obviously interpret this and make sure our diagram is correct. So it says that a canoe leaves the dock. So the first canoe leaves the dock and travels a certain distance at a certain direction. So southwest, southwest. I'm going this way, so I'm going to start over here. Right, so you have your little compass because it's a compass direction question, right? So south 46 west. So I travel, and this is 46 here. This angle formed between the south and the actual path being traveled is 46. And basically this point right here, right, I stop here. This is my dock. And this is C1, right? This is canoe number 1. And actually gave me a distance. So I'm going to go ahead and label that this direction with also with a dimension. And it says that the second canoe leaves the same dock, travels 4.8 kilometers until the first canoe is directly due south of the second. So that means that you're going to end up perfectly lined up in the north-south line. So in fact, they don't give us a direction, but they do give us a distance. And we travel until we stop here. We're directly due south, right? Due south, this one here. And they also give us a distance here, 4.8 kilometers. So this is canoe number 2. And in this case, they want us to find this distance. We're going to call this x here, this distance there. Could call it lowercase d if you wanted to. So how do we proceed here? We have two sides. We don't have a single angle inside of this right now. So how would you do that? Do you see parallel lines somewhere? If you think about it, this is because this line represents the north-south line essentially. So does this one here that we started off with, right? So this line is parallel to that line. And can you make a Z? So let's try. Go this way, then this way, then that way. They're alternate interior angles here. Careful, we can only do this because this north-south line actually ends up being part of the triangle. How do we know that? Well, because we were told here that that is the case, okay? Otherwise, you want to leave it dashed. You don't want to make it solid anyway. So there's our triangle. This side should be a little longer than that one if you drew it to scale. But now, right, now that we were able to do this, we have our pair. So essentially you can use the sine law. So let's go ahead and see what we can do. So I'm observing here. How would I be able to find this side? Well, I would need the angle across from it, this whole thing here. I don't have it. So I can't even go there. This is a two-step question. I do have a side length here, which will allow me to find this angle. Once I have this angle, I can easily find the third one. And that's when I can solve for the side. So it's a two-step question. So lots of work here. I'll pause for this part and solve the first section here for that angle C2. I solve for angle C2. Notice my steps. I set it up with my pair, C2 over the side. Sine of C2, which is your x, right? You cross multiply this way. You divide by 4.8. And then I kind of after this, I say, well, C2 will be sine inverse of what I got here. So you can kind of skip that step where you turn this into a decimal. So you can go straight to here if you want, then that's your angle. So now we're going to go ahead and find angle D for dock, right? So we're going to go and figure that out. And that's 102.36 degrees. That's also important to us. Right, so now I can go ahead and solve. I'm going to use the same pair that I was already, sine of 46, that is, over 4.8. And that is sine of 102.36 over x, because that now I can actually solve for x. So we're going to fast forward that. And there it is. 6.52 kilometers apart. Just a little breakdown of marks. So the interpretation, this would be a 2-mark question because I need to be able to interpret it, and also this step right here would be a concept. So that's a mark right there, plus the mark for drawing your triangle. You would get a mark for this whole step here. You would get another full mark for that step right there. So 1, 2, and 4, because this is worth 2 marks. This step would probably not, if you miss it, if you get it wrong, you'd lose marks, but it's not necessarily getting you marks per se. Second question, so take a moment, write it down. A boat is delivering supplies to 2 lighthouses. They are 12 kilometers apart. We don't know if they're directly across from each other. We can't assume that. It doesn't say they're due east or west from each other. So that is just worth mentioning. So they're 12 kilometers apart at a distance of 9 kilometers from the boat. Lighthouse A is located at north 30 degrees west. Very important there. And lighthouse B is located north 50 east. Distance unknown for that one. So picture this situation. A boat is traveling to these 2 lighthouses. So, right, we're going to have a triangle formed between the 2 lighthouses and the boat. We're delivering supplies, and they're 12 kilometers apart. So you kind of have to picture a little bit. So sometimes a rough draft is the way to go. You have to consider the fact that you might have to erase and start over. I'm just looking at both of them are looking north 30 degrees west from the boat, right? So this is looking out from the boat. You would be looking at a direction of north 30 west for lighthouse A. So where is northwest? Northwest. So lighthouse A is here. And northeast is over here. And the boat would obviously be here somewhere. Don't line them up perfectly. I don't want students to do that. They always think it doesn't say they're due east or west from each other. So I will purposely offset them a bit, okay? But we do know that the distance is 12 kilometers. We do know that those towers are 12 kilometers apart. And at a distance of 9 kilometers from the boat, lighthouse A is north 30. So the boat, you decide where you want to place it. We're going to call this boat. And you almost want to think of it as that's where you start. So towards tower A would be north 30 west. So let's draw that. North 30 west, 30 towards west. So the angle, the small angle here is 30. And then you have north 50 east. So that angle should be a little bigger. But we're not drawing this to scale. So this here would be 50. Right? So they're both off of the north side. They're turning 30 this way, 50 that way. This is actually, and sorry, we had that this was 9 kilometers, right? From the boat to tower A or lighthouse A, it's 9. So 30 and 50 are right next to each other. So that is just an easy case of adding it up, and you get your 80 there. That immediately you see that there's a pair. And what we're trying to do here, I didn't write that down, but they're basically going to ask what is the angle at B, and also what's the distance between the boat and B. So we're going to go ahead and I'm going to add that to the question. All right, so yeah, I added this part right here, the questions that they were going to ask. So calculate the angle at from the perspective of lighthouse B, and I go ahead and solve that here. And then they're asking us a distance between the boat and lighthouse B. So they're asking for this here essentially. So we're going to call that X. And I'm going to go ahead and solve that as well. All right, so there are my calculations, a distance between boat and lighthouse. So I start off with the pair I know. So on the other side, you'd have sine of A, which I technically don't know yet, over side of X. But I do have two angles, so I subtract that from 180 to get A. I restart the original expression I had here, the equation, and then I go ahead and solve for X, and there it is. So I answered A and B, and that is it for this section. Also, I want you to practice questions. So page 126, 12, and 129, question 8. I want you to do 9 as well, even though it's not a word problem.